Let's see here. We're going to learn about addition, subtraction, multiplication, and division of decimal numbers. And this will be perhaps a bit of a review, maybe not. Depends on your perspective. So decimal numbers, of course, can look like this. They are written kind of in the form that we'd prefer. They're not written as fractions. Some numbers that are written as fractions, when you write them as a decimal, they go on forever and ever and ever. So it's not always convenient to write them as a decimal. Of course, negative numbers can do it. Negative 400 by itself, that's written in decimal form. Even though it doesn't have a decimal point, there's an implied one there, and you could put a 0 after it if you wanted to. At any rate, we're just going to talk about addition, subtraction, multiplication, and division. So 317.05 let's say we want to add 39.714 to it. Well, here's the trick. You're going to do addition as you would kind of in the old school manner. Meaning we're going to write them out. And again, we're doing none of this with a calculator. You're going to line up the decimal points. So lining up the decimal points matters for addition and subtraction. Lining up the decimal points won't matter for multiplication, and then it won't even be possible with division the way we're going to do it. So your decimal points need to line up nice and perfectly. As you can see, they do right there. And you also want to line up your each place, the tens place, the ones place, and then the decimal places. And then the decimal point will end up in the same place in the sum. Along the same line. One thing you can do, here this 4 is lined up with nobody, so what could we technically put here? 0, exactly. And now we just do the addition. We just proceed. 0 plus 4, 5 plus 1, 0 plus 7, 7 plus 9 is 16, so bring down the 6, carry the 1. 1 plus 1 plus 3 is 5. And then just 3 plus, technically there's another 0 here, though you don't have to put it. We end up with 356.764. And so decimal addition is really pretty straightforward. Line things up, do the addition like normal, and you're good. Make sure the decimal point is in the same place it was when you started. Now, all your rules for negatives and positives still apply here. If you made that negative 317.05 plus 39.714, you could have actually done 39.714 minus 317.05. And so that would have gotten a little bit interesting. And so we can do the subtraction of this, be a good review. So here's where it gets funny. Remember, you have a negative plus a positive. Now here's the thing, the negative number, the 317.05, its absolute value outweighs the 39.714. So what will the sign of the answer be? Negative, exactly. This negative number is more inherently massive than this positive number. So this thing is going to drag this positive number way down into the negatives with it. Once you know the answer will be negative, you can still do the larger absolute value number minus the smaller absolute value number. And just be sure to line up your decimal point and line up each of the places. Well, once again, we're going to put a 0 here. We're going to do old school subtraction, and then whatever we get for the answer is going to come after a negative sign. It's going to be a negative number. Okay, 0 minus 4, we can't do it, can we? So we need to borrow, if you remember that term, from this guy and say that it's really 10 minus 4, which is 6. 4 minus 1, 3. 0 minus 7 we can't do, so once again, we're going to have to borrow. And we have 10 minus 7, which is 3. Line up your decimal points. Now we have 6 minus 9, can't do it. So we're going to borrow a 1, and really we're going to make that 16 minus 9. 7. So lots of borrowing happening here. Now we have 0 minus 3. Again, can't exactly do that. So we're going to borrow 1 from there, and now we really have 10 minus 3, which again will be 7. And then we'll have 2 minus 0, which is nothing to write home about. It's just 2. And so we get 277.336, but remember, that's really supposed to come after a negative sign. So we end up with negative 277.336. So the bottom line for addition or subtraction of decimal numbers, line up the decimal point and all the place values and add or subtract like normal. Put the decimal point in the same position in the final answer. And so that's addition, subtraction. It proceeds pretty much very similarly to the way we've already been dealing with it. Any questions on that? Very good. So addition, subtraction, your bottom line, line everything up. Get everything lined up, get the decimal point lined up, and you're good to go. You might have to do a lot of borrowing in subtraction. Now let's talk about multiplication. Multiplication of decimal numbers is going to work a little differently. Here, lining up the decimal point doesn't matter. It's irrelevant. It's not going to help you. We're still going to do old school multiplication though. We're going to put the one number over the other. Here, the final answer will have the same number of decimal points, or rather, the same number of places after the decimal point as the total number of places after the decimal point from your initial numbers. That sounds a lot more confusing than what it's going to end up being. That's really not going to be so bad once we get down into it. Remember to respect the signs here. I'll write this down. A positive and negative number multiplied together yields a negative. Two positives or two negatives multiplied together yields a positive number. So that rule is still in place. That's not changed at all, just because you're talking about decimal numbers in specifically. So let's see here. Let's think of a good example. Let's say you wanted to do 213.56 times negative 31.7. You're multiplying. Let me make that a little more clear. You're multiplying these two numbers together. And we might need a little more space. So you have a positive multiplied by a negative. What kind of number is that going to yield? A negative number. Once you know it's negative, slap your sign down there, and then you can do the multiplication. And you don't have to worry about putting your sign down. And really, you don't even have to worry about lining up the decimal point, as I promised. Lining up the decimal point no longer matters. What you're going to do, you notice that this number here has two total places past the decimal point. 5, 6, there's two. This number here has one total place past the decimal point. So after we multiply, the final answer, 2 plus 1 is 3. The final answer needs to have 3 places after the decimal point, at least initially, and then maybe there will be some zeros we can drop, maybe not. But basically, we're going to kind of ignore the decimal points until we get to the end here. And we're just going to do old school multiplication. Start with the 7 and move it through here. So this is where you really got to know that 12 by 12, specifically a 9 by 9 multiplication table here. But a 12 by 12 would encompass that. 7 times 6 is what? 42. So we put the 2 down, carry the 4. 7 times 5 is what? 35. We add the 4 onto it, and we get 39. So now there's a 9, carry the 3. 7 times 3 is what? 21 plus 3 is 24, so put a 4 down, carry the 2. 7 times 1 is what? 7 plus 2 is, so it's just a 9. We don't have to carry anything. And then 7 times 2 is what? 14. Yeah, we're going to need a little more space. That'll work. All right, so we've done the multiplication with the 7. I'm going to clear off all these top numbers. Now remember, when you go to the next line, now we got to do this 1 here. You got to put a 0 there. And the reason is a little hard to explain, but if there are no decimal points, that's because this would be the tens place. And so whatever we multiply by also needs to be multiplied by a 10, which is the same as putting a 0 down. And now we bring the 1 through. 1 times 6, 1 times 5, 1 times 3, 1 times 1, 1 times 2. So that one was easy. Multiplying by 1 is really easy. Finally, we got to multiply this 3 through. You need another 0. You need 2 zeros. You need 1 more than you used in the previous line. And now you can do the 3. 3 times 6. So 8, carry the 1. 3 times 5, 15 plus 1 is 16. So 6, carry the 1. 3 times 3, 9. Plus 1 is 10. 3 times 1 plus the 1 is going to give you 4. 3 times 2, 6. So we've swept through all the numbers. Now we're ready to add all these up and then deal with the decimal point. And then deal with the decimal point. 2 plus 0 plus 0. I'll use even a different color here to help out. 2. 9 plus 6 was 0. 15. So 5, carry this 1, but it's just added now. 1 plus 4 plus 5, that's 10, plus 8, it's 18, carry a 1. 1 plus 9 is 10, plus 3 is 13, plus 6 is 19. So 9, carry the 1. 1 plus 4 plus 1 is 6. 1 plus 2 plus 4, 7, and then this 6 just comes down. Now, is the answer 6,769,852? Exactly. Exactly. We had 1, 2, 3 total places past the decimal point between the two numbers. So our final answer needs to have 1, 2, 3 places past the decimal point. And so the final answer is actually negative 6,769.852. Any questions on that? Does it kind of make sense? Kind of clicking? How many of you this is review for you? That's good. How many of you are happy to kind of see it again or use it a little bit? Good, good. Yeah. Especially because we're not allowed to use calculators, remember? So multiplication of decimal numbers works just like that. So we have different rules for addition, subtraction, multiplication, and division depending on the type of number we're dealing with. If we're dealing with whole numbers, it kind of, technically it would be doing it this way, but without decimal points involved. If you're talking about fractions, you do those a different way. And then if you're talking about pure decimal numbers that have actual places past the decimal point, well, we've developed a different strategy. Finally, let's talk about division. First, real quick, let's reestablish our vocabulary. The thing that's doing to the dividing is the divisor. The result of division is called the quotient. The value being divided, this one's not as well known. This is called the dividend. It is what is being divided. Kind of makes sense because if you own stock in a company and they have a surplus of cash they want to give out to all of their stockholders, they'll call that a dividend. They'll say, if you ever played Monopoly, you do one of the cards says you receive a dividend of some, I don't remember, $50 maybe. And so the dividend is that extra cash they want to pay out to their stockholders. They have to divide it up among all their stockholders based on how many shares you own. So it's the thing that is being divided, so it's called the dividend. That's a good way to remember it. Well, now here's the thing. The divisor should not ultimately have a decimal point in it. Meaning, you're going to have to divide by decimal numbers. You can't avoid that. So what we're going to do is we're going to make an adjustment. We would like to get rid of the decimal point in the divisor, but we can't just do that arbitrarily. We can't just say, okay, decimal point hocus pocus is gone. You're not allowed to just remove it for no reason. You have to have a pretty darn good reason to remove it. So what we're going to do, here's what we'll do. Move the decimal point in the divisor however many places it takes to basically no longer have a decimal point. You move it to the right until it's no longer important. Then move the decimal point in the dividend the same number of places. Even if it still ends up having a decimal point. You move it the same number of places. So let me bust out my calculator. Because I'm going to create something cool for us. That's what we're going to do. And because we adjusted both the divisor and the dividend, whatever result we get is good to go as the final answer. Meaning I moved the decimal point on the divisor, I counterbalanced it by moving the decimal point on the dividend the same number of places. The quotient doesn't change then. It's like whatever you do to the left-hand side of an equation, if you do it to the right-hand side, the equation's still balanced. Even though it might look different now, it's still balanced. It's the same idea. We're going to have that balance, and so the quotient, the answer, is going to be completely the same. So let's try one of these bad boys on for size. And these are just the rules as I see them in kind of plain speak. There's probably a more formal way of writing out the rules, but we don't necessarily have to split hairs over it. Let's try one out on for size here. Let's try an actual example. How about 317.534 is being divided by 1.4. Now I'm going to have to delete all this text out here, so I have room to do it. Let's give ourselves a little space on it. Oops. And let's shrink it a little bit. Set a good precedent. The first thing you're going to do, let's see, 1.4. This is the divisor. This is the pivot point, the key to it all. How many places would I have to move the decimal point so that it no longer has a decimal point? Just once. If I move this once, that's going to look an awful lot like 14. Now you're tempted to say, okay, this thing inside was 3 decimal points, so I got to move it 3 times. No, you're not allowed to just do that. You can't just move it how many times you feel like. You have to move it the same number of times you moved the one in here. So because you only moved it 1 decimal point for the divisor, you only get to move it 1 decimal point here in the dividend. And so this division is basically just going to become 14 being divided in 2. We got to move this decimal point. Oh, something got messed up. There it is. We're going to move this decimal point 1 place to the right, and it's now going to go right here. It's now going to go right there, 1 place to the right. And then we're going to line up the decimal point above. So it is in the same place. So for division, lining up the decimal point kind of takes on a completely different meaning here. Now it kind of sucks because we're using 14 here. And 14 is not on our 12 by 12 multiplication table. So we might have to strain our brain a little bit to figure out multiples of 14, basically. But let's just try it out. Does 14 go into 3? Nope. Does it go into 31? Twice, yeah. You can see it'll go in 2 times. And then if you're not sure, 14 times 2 would be what? It'll end up 28. And so 28 was the closest we could get to 31 without going over, because the next multiple of 14 would have been 42, which is too large. And so now we complete the process. 31 minus 28. I'll just give you 3. Yeah. Bring down the 7. How many times will 14 go into 37? Again, only twice. If you try to do 14 times 3, you're going to end up with 42 if you do that multiplication, and that's going over. So it's going to be twice. You're going to get 9. Bring down the 5. Now it's kind of hard off the top of our heads to see how many times 14 goes into 95. So you're just going to have to experiment a little bit. We know 14 times 2, 14 times 3, probably not enough. Let's try 14 times 5. Whoops. You're going to end up with 70. I bet we could go larger than that and still not go over 95. 14 times 6 then, well, you just add 14 onto 70. You'll end up with 84. And there, that's about as large as I bet we can go without going over 95. So 14 can go into 95 6 times. You're going to get 11. Bring down the 3. And things are getting pretty interesting here. Well, how many times does 14 go into 113? Well, 8 times. I think you're going to be right. Let's try 14 times 7. We can get sneaky and just add 14 onto 84. You're going to end up with 98. But I bet I can go one more than that and still not cross over 113. So yeah, let's try 14 times 8. 112, exactly. And then 112 is just snug under 113. You'll end up with 1. Carry down the 4. And hey, isn't that just perfect? Isn't that just peachy keen? How many times does 14 go into 14? 1 time. And this is just to show you end up with a 0 remainder. And I know it's the remainder, not just because I arbitrarily hit 0. It's because I hit 0 and there's nothing else to bring down. Once you know that, you're done. So we end up with 226.81. And we don't have to move the decimal point on that at all, because by moving the decimal point here initially and here initially, we took care of it already. This thing's already balanced out and it's the exact same answer. So 226.81 is our final answer. Let's try one more. And I want to do one that's fun. Give me 1 sec. Let me find one that's fun. Let's do one more. Let's do 0.31 and divide it into 5,418.8. Now we have 0.31. How many times do we need to move the decimal point? Twice. That's going to be what brings it into being what looks like a whole number. So we move it twice. We're going to have to move this twice as well. Now we moved it. What do I need to fill in here?
0.
You're going to fill a 0 in, yeah. And if you don't believe me, it's because moving the decimal point to the right twice is kind of like multiplying by 100. Oops. Oops. And so actually, the decimal point's gone now. And this doesn't even look like decimal division of numbers anymore, but that's okay. So it's really just like we're dividing 31 into 541,880. So 31 will go into 54 how many times? Just once. And now we definitely don't do a 31 by 31 multiplication table. 23. Bring down the 1. How many times does 31 go into 231? It's probably not pretty. 7 times? Yeah. Try it out. You get 217. If I go to the next level, and we'll write it out just so we know. That's too far. That's going over 231. So it's going to go in 7 times. Do minus 217. You end up with 14, it looks like. Bring down this 8. How many times does it go into 148?
4.
Yeah, it looks like it's going to be 4 times. If you try to do 5 times, you're going to go too far. So it's going to go in 4 times. Bring down this 8. Oh, 31 is going to go into 248 cleanly. 31 goes into 248 8 times, as we saw over there. How do we deal with that? Well, you're going to end up with 0. You can't just say that we're done and that's the remainder because we still have another value to bring down. How many times will 31 go into 0? 0 times, but we still need to put that 0 here. And then you come down here, then that's the remainder because there's nothing left to bring down. And so that's a good place to do addition, subtraction, multiplication, division of decimal numbers. The next subject matter we're going to cover is very large, and so I don't want to start it today. So today will be a rare day where we're just going to get out early. Life goes on. Maybe you can go eat some leftover Super Bowl food. How many of you were happy with the Super Bowl results? How many of you wanted the Chiefs to win? How many of you didn't care? I'll be honest, I wanted the Chiefs to win. I got nothing against Tom Brady, but Patrick Mahomes went to Texas Tech, which is my alma mater, and I wanted him to win. He did win last year, though. He won the Super Bowl last year. No one thinks his career is suddenly over because he lost the Super Bowl. He's going to be the best quarterback in the NFL for years. Plus, I put money on Tampa Bay so that If Tampa Bay won, I'd be happy. If Kansas City won, who I wanted to win anyways, I'd still be happy. So I was happy with the result either way. So y'all have a great day. Your test scores should be up later today in Canvas for test 2. Not that many.